Okay, so step one is end behavior. This is even degree. A is positive. What is the end behavior? Up, up, right? Just like x squared is up, up. So is x to the fourth. One more time, I just want to tell you real quickly. You don't have to have that chart memorized. If you can remember x squared and x cubed, that's really all you need to know. Because x squared positive is up, up. Negative just makes it go down, down. X cubed positive is down, up. Negative just makes it go up, down, right? So if you can just remember those things, any other degree that's a multiple of even has that end behavior. Any degree that's a multiple of odd has that end behavior. And then 2, the y-intercept, this is already in standard form. So whatever that last number is your y-intercept. And then step 3, using synthetic division to get your factoring started. Remember, we want factors because from factors we get zeros and we can graph those points. So we already know that x plus 2 will work. So when it's in factored form, what number do I put in this little box? Negative 2, right? And which term is missing? There's a missing term, the x cubed. So we're going to put a 0 there to hold the place. Okay, so we just do math. Math occurs here. Math ensues. Just don't pay attention to anything I say. Okay. So then here we add our x's back in, starting with which degree? X cubed, right? And then we say, okay, that's fine. I have 4 terms. I like I do like factoring. I like to try grouping to factor here. You do GCF on the first one, you get to here. That's all well and good. What happens in that second group? What's the GCF there? You can't. So here's the thing. One of the skills that we cut out of this unit because we were short on time is what to do when you need to figure out another root. Because see, when the problem began, I gave you a factor. But when we get here, we still have to break this down even further, but now we don't know where to start. We don't have another 0. We don't have another root. And what I'm about to write down, I don't want you to write down. But it's good for you to see it. This is what we cut out. When you get to a place like this, you basically have to guess and check for roots. But you don't have to just use any number willy-nilly. There is a method, which is only barely better than willy-nilly, where you take the factors of the last term, all the plus or minus factors that could possibly go into 6, divided by all the plus and minus factors of the A term, which in this case is 1, which makes it really easy. It gets crazier when this is like a 6 as well or something like that. And any combination of these are zeros for you to try out. So it's really just a guess and check. It's a trial and error. So like you would try positive 1 over 1. You do synthetic division, and if it was a 0, what would you be looking for here? 0, right? So if you tried, so let's say you tried 1, the remainder was not 0. You'd say, okay, that doesn't work. Then you try negative 1. Then you try 2 and negative 2. You try 3 and 6, positive and negative. If there were other numbers under here, well, now you've got fractions to check out. Now, we didn't get to that, so you don't have to do that. But it's good for you to see, because if you're going to take college algebra in school next year, you will definitely, they're called P's and Q's. It's called the rational root theorem. So we're not going to do that. But what we are going to do right now is I'm just going to give you another 0, okay? Like I'm just going to tell you that this works. 1 works. So in order to continue factoring this next section, I want you to do synthetic division with 1. Okay, this is a 0, but not from the original problem. Because remember, we've already factored out 1 degree less to these coefficients. We're trying to break down this. So when you do your next round of synthetic division, you're going to use these coefficients. Okay, so take a minute and do that, and you will be able to factor again when you get to this new step. What am I trying to say? When you do your synthetic division here, you'll be able to factor easily. Okay, and then go ahead and try and finish out the problem after that. So, by the way, when you go to enter your x's back in here, which degree are you starting with? Squared, right? Because this step was x cubed, and this step was x squared. So we've got 1 x squared minus x minus 6 that we need to factor. So basically it's the same as what multiplies to negative 6 and adds to negative 1. I saw it on your papers. Negative 3 and 2. And then I saw a bunch of this on your papers. X minus 3 and x plus 2. I don't think you were necessarily finished, but you just kind of stopped there. I have 2 more factors to take into consideration. Okay, that's x minus 3 and x plus 2 is just from that last step. But I also have the factor from this 0 and the factor from that 0. So this is a factor of x plus 2. Now, is it okay for me to have more than one x plus 2? Yes. So this x plus 2 comes from here. But I also have this x plus 2. So what I'm going to write here is just that that's squared. Right? You can list them twice, just x plus 2 if you like. But I like doing it squared because it reminds me that I have an even multiplicity, which I'm about to use that information. And then the 1 gives me a factor of x minus 1. So we have this information. We're going to use that by figuring out our zeros, their multiplicities, and the multiplicity tells me if it bounces or crosses. So this is a 0 of 3. Its multiplicity is 1, which is odd. So what's the behavior of the graph there? Cross. Cross there. This is a 0 of negative 2 with an even multiplicity. That means bounce. This is a 0 of 1 with an odd multiplicity. It will cross. So putting all of this together, our end behavior is going to go up, up. So I'm going to just put those there to remind myself. I have a y-intercept at 0, 12, which is somewhere up here. A 0 at 3, 1, and negative 2. Now that step 4 is an optional step for when it's necessary. So watch me draw in this graph and how I'm going to use my context to see when and if I need to do step 4, which is the mid-interval point. So I know that here it's going to bounce, and that it has to go off into that direction. So I know my graph has got to go like this. The y-intercept is close enough that I can just turn there. Right here. This is when I need a mid-interval point, because I don't know if the graph is going to turn quickly or if it's going to go down this way or even way down low. So we want a mid-interval point there. Now you could, if you wanted to be very, very accurate, find mid-interval points between here and here or here and here. But to my mind, that's not really necessary. It's not going to improve the graph very much because we're really just sketching it. But definitely between these 2 points. And what's a good point between those 2 points? 2, right? So for step 4, we're going to let x equal 2. And how do I find the y value for that point? You plug it in. But I'm going to show you something else that we cut out of the unit, and this is very helpful. You don't have to remember this, but I just want to show it to you. Using synthetic division, so when I plug in 2 for x and find y, that's called evaluating the function. I'm finding the value when x is 2. You can use synthetic division to do the exact same thing. It's the remainder. So I'm going to do synthetic division for 2, and whatever the remainder is the y value. So it just goes faster. You don't have to remember this. You don't even have to really care. It's just good for you to see, and it's kind of interesting. So when x is 2, y is negative 16. So it's another useful thing that synthetic division is good for. So then I just put that in to negative 16 somewhere crazy down here. Okay. Great. Now remember again, I showed you that synthetic division thing. You don't have to remember that. I know you'll remember to plug in 2 to get y because That's basic algebra functions. We've been doing that forever, since we were algebra babies. Okay, so I just wanted us to work through that problem.